Okay, this is the second part of the key. So we have CO, and when we look at valence electrons, we get this. 10 valence electrons between the two of them. When we look at octet, if everyone was satisfied, we get this. 16, which tells us that they're going to be sharing quite a few electrons. So 16 minus 10 shows that they're sharing 6. That means there, must be 3 bonds. How many unshared electrons? Well, they have 10 valence going in, they're sharing 6 of those. There will be 4 unshared valence electrons. So if we're going to put 3 bonds between these two, there's really only one place for them to go. The fact that we have 4 unshared electrons would give us something like this. And let's check octet. Carbon feels surrounded by 2, 4, 6, 8. Oxygen feels surrounded by 2, 4, 6, 8. We're good, and that's the structure for carbon monoxide. Now for CO, when we do our valence electrons, we get something like this. 16 valence. For octet, we get 24. This means that they will be sharing 8 electrons, and hence forming 4 bonds. If they are sharing 8 of their 16 electrons, it means that there will be 8 unshared electrons. The fact that we have 2 double bonds and only 4 bonds and only 2 locations in which to put bonds means there must be 2 double bonds, and of course we know that carbon and oxygen are both prone to double bonding. Now to put in our unshared pairs, carbon is satisfied. Carbon's got 2, 4, 6, 8 electrons surrounding it, but neither of these oxygens is. So we'll go ahead and place our unshared pairs out here on the oxygens. Check for satisfaction with octet. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Everyone's happy, and that's the structure for CO2, carbon dioxide. Now, when we look at the structure for O2 and we do our valence, we get this. 12. For octet, we get 16, which means that they will be sharing 4 electrons or forming 2 bonds. If they are sharing 4 of their 12 electrons, this means they have 8 unshared. So, to start off with 2 bonds, we put 2 oxygens side by side. They must be double bonded. And for 8 unshareds, 1, 2, 3, 4, 5, 6, 7, 8, we now check octet for each. 2, 4, 6, 8, 2, 4, 6, 8. Everyone's satisfied. We have the correct number of bonds and the correct number of unshared pairs. That's the structure for an oxygen molecule. I've laid out the Gooch math. We can see that they're sharing 6 electrons, which means that they will have 3 bonds, and there will be 4 unshared electrons. So to put 3 bonds between 2 nitrogens means we must form a triple bond. And in fact, nitrogen is well known for its ability to triple bond. It triple bonds very commonly. There are 4 unshared electrons, and really only one place to put them. It's also handy to remember that coming into this, nitrogen would have looked something like this. So really, we're just preserving this unshared pair that already exists on nitrogen. Okay, let's check octet. 2, 4, 6, 8. Good. 2, 4, 6, 8. Good. We have the correct number of bonds, the correct number of unshareds, and everyone's satisfied. That's the structure of the nitrogen molecule. We now have nitrogen triiodide, Ni3. So I'll do the math first. Okay, so we find 26 valence electrons, 32 octet. So this compound has 6 shared electrons, or 3 bonds. There are 20 unshared pairs, and with 3 bonds and 1 central atom, this is a pretty easy one to figure out. There are your 3 bonds. As far as your unshared pairs go, it's helpful to remember that before we began to bond it, iodine looked like that. And we assume that all of these unshared pairs on iodine are still intact. It's not always the case, but it often is. So let's add those. And check octet for everything. Let's see, 2, 4, 6, 8, 10, 12, 14, 16, 18. Oh, we do have a problem. We're shy, so here's where this comes in. I notice that I'm shy 2 unshared pairs. I only have 18 unshared pairs. And if I go through and check my octet for each of these atoms, is each of them satisfied? 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6. Nitrogen is not satisfied. So we have to remember that going into this, nitrogen already had an unshared pair of its own, and so is likely to have kept that. Let me rearrange the drawing to look more like that, and then we'll go ahead and insert that unshared pair on nitrogen. Now we have 20 unshared pairs, 3 bonds, and everyone is satisfied from an octet perspective. That's the structure for Ni3. Our last substance is H2S. This is actually hydrogen sulfide. Let me do the math first. So we see that there are 8 valence electrons, 12 octet to make everyone happy, which means they'll be sharing 4 electrons or creating 2 bonds, and there are 4 unshared pairs. So we'll put sulfur right in the middle, and we won't worry too much about the geometry yet, though it's typically drawn like this. You'll understand better why soon. So hydrogen's happy with 2. Each hydrogen is happy. We have the correct number of bonds, but we have 4 unshared pairs to distribute. So they'll go right there. And again, it's helpful to remember that sulfur coming in had 2 unshared pairs. So we've just preserved those. That's the structure for hydrogen sulfide. I hope you got them all right.